Purpose. The purpose of this lab was to show how an eco column is used to see how different factions of life connect and depend on each other. Also, it is used to test controlled tests and observations.
An eco column is a close, sustaining system in which a water chamber, compost chamber, and terrestrial chamber are dependent on each other's productivity.
Hypothesis. Our group believed that everything would survive.
4 2-liter bottles, composter, regular grounder, daisy plant, bulbs, 5 crickets, lots of worms, mosquito hawk larvae, water, fish, rocks, elodea, duckweed, and a betta fish, which I already said fish.
This is a roughly written idea of our data table. It has all the data from every single week that we tested. It shows dissolved oxygen, pH, nitrate levels, CO2 levels, the temperature, turbidity, odor, plant, fish, and how the land analysis was going. We couldn't figure out how to put it in a nicer format for the video. Sorry ahead of time.
This is the analysis portion of our project, and we're going to start by talking about the most obvious correlation, or what we think is a correlation between the fish death and the CO2 levels. So we noticed that as the CO2 started to drop, the fish kind of died. It didn't quite get to 0, but it was at about a 0.3, and we know that was a bit too low for the fish to survive in. And we think the fish died due to the lack of dissolved oxygen. However, it could have also been because of the moss that got stuck in it the week prior to its death, and not being able to use the gill did not allow it to breathe the air, or breathe the oxygen. And it could have also been because of the ick that it got.
Alright, so for this project we decided to use the carbon cycle and show how it is represented inside our eco column. And starting in the aquatic chamber, the carbon dioxide gets respirated by the fish into the water, which is then absorbed into the plants through photosynthesis and put back in the water for the fish to respirate again. Also, when the water evaporates, the carbon dioxide and oxygen goes into the air, and when it condensates, it goes back into the water. So that happens. Also, in the terrestrial part of the eco column, the photosynthesis happens in the plants, and it takes in the carbon dioxide and puts out oxygen, which the animals and the creatures inside the eco column respirate again, and it goes back into the air. The whole column is connected, so the air can flow between all the chambers. So that's how that works.
We also noticed, and you'll see with our data table, that nothing really changed significantly throughout the whole process. The turbidity stayed fairly constant. The temperature stayed fairly constant with a variation of about 5 degrees Fahrenheit. The turbidity stayed fairly constant. It was 1, I said it again. The turbidity started at about 1 out of 5 and ended at a 4 out of 5, and there was a big bloom of algae in the water, and the duckweed expanded significantly. The water was neon green at the end. Also, the worms, we noticed when we put them in, were very weak and skinny and did not move a lot. However, at the end, when we took them out, they were pretty plump and moved a lot, squirmy. Also, we put in some grass seeds, and by the 3rd week, they were about 5 inches tall. And
There you go.
This is a continuation of the analysis. So Tracy was talking about pH levels, right?
So the pH levels also stayed fairly constant. There was, at the very end, a shift from a 7 to an 8, and then it continued to stay at an 8 for the remainder of the experiment, and we don't really think that had anything to do, or didn't have a big effect on anything, because everything was already either dead or blooming, so there was no change because of that.
Okay. Well, I want to talk a little bit about the eutrophication of the aquatic chamber, because towards the end of the last couple of weeks, it was pretty crazy how much the duckweed expanded and the algae bloomed and how it turned neon green. And so there was the compost section of our eco column was right above it, and there was holes down into the aquatic chamber, and we think that with all the condensation, the water cycling through, that we would see water drop from the compost section to the aquatic section, and just how runoff works in a farm when it runs into rivers and streams and lakes and causes cultural eutrophication. This caused eutrophication in our aquatic chamber and caused it to just expand super and add all this abundance of nutrients. And towards the last week of our experiment, we started noticing that it actually kind of started to die because it was so much.
There was not enough CO2 anymore. The levels had
decreased significantly.
Yeah, we noticed that the duckweed had pieces of brown, and it wasn't as vibrant as it was before.
So where our eco column was in a window by the sun pretty much the entire time. I know some people put theirs underneath grow lights, but we didn't feel like it was necessary to put ours underneath a grow light.
And it didn't really seem to matter or
Yeah.
not. It actually worked really well since the temperature was fairly constant, although it could have been just the time and the day that we would take the temperature.
But I feel like the window also helped to keep the temperature fairly warm and helped with condensation and the sunlight.
It was a more realistic representation of what it would be in the wild.
I saw the ones in the grow lights, and they just didn't seem like they were doing as
Our
well.
Our plants grew a lot more than theirs did, and some of the others, and same with the aquatic chamber. It also flourished a lot more. Decomposition or compost chamber did seem to work, however, it wasn't working at the same speed as other columns were, and it could have been due to the lack of turnover that we had. We know that we are trying to simulate a realistic, or what it would be like realistically without the turnover, but it did seem to, it would have been better probably to be able to do that, because
it just sat there.
It just sat there, and the moss, there was a layer of
mold or something like that.
Something that was at the top, but it did benefit the aquatic chamber.
It did. It totally did. I think this concludes our analysis portion.
So this is the conclusion. The purpose of this lab was to see how the eco column survived over the 8 weeks, and how we saw the different things connect and everything. Our hypothesis was that we thought that everything would survive, but it ended up not surviving as well as we thought. The fish died, and then after that our ecosystem spiked, eutrophication wise, and then started to just deteriorate after that. We learned that ecosystems are very sensitive when exposed to human activities, like us messing with it or tapping on the fish or whatever, and other sources. We have learned a lot of things from this experiment, and how sometimes the ecosystems depend on each other, and this lab was a little different because ours is obviously controlled, and we try to control it. Decomposition of our fish, I think, really affected the turbidity of the water, and it decreased the plant photosynthesis, which is something we kind of saw the last week of the lab. It was really kind of cool to see the way the plants kind of bloomed from the eutrophication that we think came from high levels of nitrates from the compost. And our pH levels are pretty consistent. They were around 7 the entire lab. Our temperature was very consistent, around 70 to 80 degrees the entire time. The very last week, though, it was 69, which a lot of factors could be for that. Since it's a controlled one, there's not as many things in it, and things die off easier and stuff like that. So we didn't really have a super complex ecosystem like one out in the real world. It was cool to kind of witness the carbon cycle, and we didn't really witness it, but we knew what was going on, and it was kind of cool to see that happen. And when our fish died, we noticed that all of the algae and the duckweed bloomed, and then a couple weeks later it just kind of all died because there was less carbon dioxide, because there was nothing else to breathe out carbon dioxide because there's no respiration in the water. So yeah, there's a lot of things. Our conclusion is that ecosystems are sensitive and need to be very balanced, and they get disrupted very easily, and our data kind of match that sometimes they're resilient in certain things, but that there's little things that can make them really kind of fall over the edge, like the death of animals, or too much of one thing that's beneficial in small amounts, like nitrates or things like that. So yeah.
Sources of error. Number 1, having our decomposition chamber above our aquatic portion of our eco lab led to particulate pollution in the water, which could have killed the fish. 2, having a sick fish could have thrown off our experiment because it died prematurely. 3, adding oxygen to the water also could have tampered with our data because we were measuring the amount of dissolved oxygen, and that would make it rise. 4, human error while taking tests could have skewed our data if we did not do it right. Number 5, different people doing the test could have led to an inaccurate representation of the data. Number 6, having the eco column in direct sunlight could have heated and cooled it rapidly, stressing the fish out. Number 7, it was supposed to be a self-sustaining eco column, but we were constantly opening it up and letting oxygen in. Number 8, plastic from the bottles melting into the water due to the heat of the sun. 9, the fish died, so our data is thrown way off because it was a large part of the experiment. 10, some of the fish had diseases, but we all were using the same equipment to test our water and everything inside our eco column, transmitting the diseases to every eco column. 11, top of our eco column was opened, letting air in and letting condensation out. 12, human error when we accidentally spilled some of the water out of our fish chamber on multiple occasions. 13, human error getting the oils and bacteria from our skin in the water when we were doing tests and untangling our fish from the weeds. 14, placing more duckweed in the eco column after the experiment had started and giving some to other people. 15, poking holes in the side of the eco column to let in air. 16, shocking the fish when we are sticking a whole bunch of equipment inside its habitat, stressing it out. 17, putting 2 little plants in the water which weren't able to keep up with the oxygen demand of our betta fish.